Today, I'm going to give you a crash course on Kubernetes. We will quickly understand its terminologies and components and look at a quick demo towards the end. Hi, I'm Rohini Gaonkar and welcome back to my channel. If you are new, thank you for stopping by. I release one video every week in the ongoing This Week I Learned series where I talk about tech tips and tools. This month, I'm going to give you a crash course into Docker, Kubernetes, scaling containers on AWS and more. So please subscribe and click on the notification button to know when my next video comes out. I also provide subtitles and chapters so you can skip ahead or watch these videos in 2x speed. In my previous video, I answered your questions on why container orchestrations in general, why Docker versus Kubernetes, and AWS ECS versus EKS, and more. We explored why just Docker isn't enough. We need container orchestration tools like Kubernetes to help us manage the tens or hundreds or even thousands of containers that are running a microservices application. In the container orchestration video, we also learned about the control plane, which is the brain, and the worker plane, where work actually happens. Before we get into Kubernetes component, let's quickly understand two important terminologies: pods and nodes. Now, a pod is the smallest deployable unit of computing in Kubernetes. It can have one or more containers inside it, similar to a pea pod. These little tiny green ones are actually containers inside a pod. So a pod can contain one or more application containers which are relatively tightly coupled so they can share the same storage and networking resources. Well, grouping containers into a single pod is relatively an advanced use case, and you should only use this in specific use cases when you need tight coupling. Or else, just go with one container for one pod model, which is the most common use case. Now, these pods are simply definitions of the containers. They don't really have the compute power. They need CPU, they need storage, they need networking to actually perform the actions that you have defined inside the container image. So where does it come from? It comes from nodes. Now, typically in a cloud environment, your nodes are EC2 instances. These provide the CPU, the storage, the networking capabilities to your pod. So you can run one or more pods inside this node. Now, nodes are the worker plane for Kubernetes. Every node will run at least two components. First is a kubelet. It's a process that will be responsible for communication between your node and the brain or the control plane. Now, it will manage the different pods and the containers that are running on this particular machine or the node. The second component is the runtime. In our example so far, we have used Docker, which is responsible for pulling that container image from the registry, unpacking that container, and then running your application. So multiple nodes like these are the worker plane. Just a quick side note, the Kubernetes control plane or the machines that had these components were previously called as masters. But we as a tech industry are moving away from such terms like masters or slaves to a better, more inclusive words like control plane and data or worker plane, or primary secondary in case of databases. So if you see any old references to these concepts, know that the work is same, just the vocabulary has changed. So Kubernetes control plane has some components inside it. Let's look at some of the prominent ones. First is etcd. It is simply a key value store that stores all cluster related data. Second is kube scheduler. Let's say you need a new pod. Now, kube scheduler, as the name suggests, keeps an eye or on watch that hey, there is a new pod, but it doesn't have a node on which it can run. So scheduler will select this pod, will bind it to a node for it to run. Now it takes a lot of factors into account to make this decision, like the pod's requirements, if there are any constraints or specifications that it needs to take care of. Third or fourth is the Kube Control Manager and the Cloud Control Manager. As the name suggests, it runs the controller processes. The word controllers actually comes from robotics and automation term of the control loop, whose job is to maintain the system state. For example, you have AC at home. You set the temperature to 24 degrees Celsius. Now, this controller will ensure that your house stays at this particular temperature. If the temperature is higher, it will turn the equipment on, or else it will turn the equipment off. Similarly, Kubernetes controller ensures that state of your cluster is maintained to a desired state. There are multiple logical processes inside it for nodes, jobs, services, accounts, etc. And the cloud controller only manages cloud-specific logic. The final and most important component is Kube API server. This exposes the Kubernetes API as a front end, so we can interact with Kubernetes. This is the only exposed remote service. So you interact with it via the REST calls, or you can use command line tools like kubectl or kubeadm. We typically use kubectl or kubectl or whatever you choose to call it. Now that you have understood the different components and the terminologies, let's quickly look at a demo. So here I have not installed Kubernetes on my machine. I have gone to the easiest route is using the AWS service called as AWS EKS, which is a managed Kubernetes service. And here I've asked Kubernetes to create a cluster for me, and I will be only creating the nodes or the pods or the containers that I need for my sample application. So now let's check out and let's talk to this Kubernetes deployment. So remember I said we talk to it via the Kubernetes API, and we can use tools like kubectl to interact with Kubernetes. So I'm going to say, hey kubectl or hey Kubernetes, tell me what are the nodes that are running. So nodes, remember the EC2 instances that are running. So I'm going to ask it to get me certain nodes. And it will tell me that, hey, these are the two EC2 instances that are running from last 116 minutes. And this is the version of that is running on them. So I can create pods on this. Now, how do I define a pod? Remember, we define a pod, it's a definition. So you write something called as a manifest file, which is in YAML. Now, this manifest file, of course, has its own definition of how you're going to define this. This you can find in the documentation. I'll provide the link in the description. But let's look at a simple manifest file for a pod. So I'm giving an API version. Typically, you just have to look for it. But as of now, I think you can just say version 1. I'm saying it is a pod, and I'm saying its name. I'm giving some kind of metadata that, hey, it's an Nginx pod. Okay. And in the specifications, I'm saying it has following containers. Now, what does it have? It has an Nginx container that is from the Nginx image. Now, by default, this will go to Docker registry and get that container image. And I'm also saying which port is this container going to be running on. This is a very simple definition. So once you define this YAML file, you can just save it. And what you do is you go to kubectl and you say apply -f, that is the file, which is right now in pods/simple pod.yaml. So I'm just going to say apply this to my Kubernetes cluster, and that's it. Now it's telling me that pod Nginx is created. How do I see this? I just say kubectl get pods. And it will tell me that yes, I've created this pod, and you can see this pod was actually just created 10 seconds ago. And that's it. Now it has gone ahead, it has created this pod. That's how you define a simple pod in Nginx. Now definitely in real world, you don't just define a pod. It doesn't make sense to use Kubernetes and EKS and all of that just if you want to deploy one pod or one container. You use something called as replicas, you use something called as deployments. which is also similar to how you define here. Now there's a lot more to unpack here, but remember that by default this pod is just inside an EC2 instance. It is not really exposed to the world right now. So if you want to expose it further to the world, you will have to define it as a service. You might have to define the ingress rules, and there's a lot more that you have to define before this pod can be exposed to the world, and I can just say HTTP IP and access the Nginx. So there's lots of things that you have to configure if you want to use this, but I hope I gave you an in general idea of how you can use Kubernetes, how we can define a simple pod, and how you can apply it. Now, before I proceed, I do want to share two important links with you. That is what you will use to learn this further. First is a workshop. So if you go to eksworkshop.com, you will find a workshop which you can use, or they have good proper steps. If you're a beginner, if you're an intermediate, or if an advanced user, they have proper steps of how you can play with EKS and Kubernetes in general. The second is definitely there is a deploy a Kubernetes application, a 30-minute tutorial which will cost you around 60 cents if you just do what it says and you actually delete the resources after the tutorial is done. But it's a good hands-on tutorial if you want to follow and learn more about this. And finally, I definitely end my videos with pricing. Well, Kubernetes itself is an open source technology, so you don't pay for Kubernetes if you're using it. But if you're running Kubernetes on EC2, or if you're using managed services like EKS, you will be paying a little bit extra for those. So always make sure you understand the pricing before you actually go and do those experimentation. And with that, thank you for watching this video. Let me know in the comment section if you want me to explain any other topics or further simplify any other topics that you want to understand. So please do like, share, comment and subscribe, and help me continue sharing technical knowledge in a simple language with all of you. Thank you again. See you next time.